Now let's do an example of calculating a confidence interval from scratch, okay? So we're going to be using this formula right here. In fact, I think I'll put that at the top. Okay, so this example says, a 2012 poll asked 166 adults whether they were baseball fans, and 48% said they were. So we've got a single poll here. Construct a 99% confidence interval for the true proportion of U.S. adults that are baseball fans. So we want to know in general, the parameter is what proportion of the U.S. adults are baseball fans. Okay, are you a baseball fan? So let's start with our formula. I'm going to write it down here. P hat plus or minus Z star times the square root of P hat Q hat over N. Okay? We're just going to go right to that formula. Now that we've built it up and worked through it, we're just going to go right to that formula. Okay, so do we have all this information? P hat is our, coming from our sample, it's our sample proportion. So this is P hat, well, in decimal form, 0.48. So 0.48 plus or minus. What's our Z star for 99%? It is 2.5758 times the square root of P hat again. If you're not sure what Q hat is, you can also just go 1 minus 0.48. I believe that's 0.52. Let's check it. Yep. Over our sample size, which in this case is 166. That's our N. Okay, now I like to calculate the whole margin of error at the same time. I don't want to have round off. I don't want to be rounding in the middle. We want to keep our answer very accurate. So I'm going to punch in this whole thing at the same time. 2.5758 times the square root of 0.48 times 0.52 divided by 166. Okay. 0.9988, so 0.999. 0.999. Okay, which is pretty close to 10% if we round that up. So our confidence interval, remember we subtract and then we add. So 0.48 minus 0.999, 0.3801, and then 0.48 plus 0.0999 is 0.5799. Okay, so that's saying about 38% to 58% if I round those. That's quite a big range, isn't it? 38% to 58%. Well, that makes sense. Our margin of error is about 10, so this is about plus or minus 10, or a width of 20 percentage points. Okay, so you might wonder, why is that so big? Let's keep going and we'll talk about that at the end. So then we're going to go down and for the same values, make a 95% confidence interval. So what's going to change? 0.48, same formula, plus or minus 95% confidence, we use a Z star of 1.96. And same numbers, 0.48, 0.52 over 166. Usually we don't do every single confidence level for one problem, but I want you to see the pattern of what's going on here. So the confidence, the only thing that changes with the confidence level is that Z star value. So 0.48 plus or minus, let's plug this in, and 0.96 times the square root 0.48 times 0.52 divided by 166. It's also good practice to do this one several times. 0.760. Okay, so confidence level, or sorry, margin of error went down to about 7.6 or 8%. So now I take, move this up, 0.48 minus 0.0760 is 0.404. 0.48 plus 0.0760, 0.556. So now we're saying about 40% to 56%. So now it's a little narrower, isn't it? All right, feel free to do the other two and just pause it and then check your answers at the end. I will go ahead and write them out. 0.48 plus or minus. For 90%, our Z star is 1.6449. 0.48, 0.52 over 166. I'll do these a little bit faster since we've gone through the process a couple times. 1.6449 times the square root, 1.6449 times the square root of 0.48 times 0.52 divided by 166. 0.638. Okay, so now I subtract and add. 0.48 minus, so now margin of error is 6%. It's going down. 0.0638. 0.4162 and 0.48 plus 0.0638. 0.5438. So that's about 42% to 54%. Last but not least, 80% confidence. 0.48 plus or minus, our Z-score is 1.2816 times the square root of 0.48, 0.52 over 166. So 0.48 plus or minus 1.2816. Oh, didn't like it. Oh, I don't need a parenthesis there because I didn't open a parenthesis. 1.2816. Okay. 0.0497. Just check that one since I messed up a little bit. Yep, okay, great. So now I subtract and add. 0.48 minus 0.0497 is 0.4303, and 0.48 plus 0.0497 is 0.5297. So now rounding, we're talking 43% to 53%. So now we're within about 10, plus or minus 5. Okay, so is that what you expected for this pattern? Let me zoom out here. So we started with the high confidence level and it was wide. And then we got narrower and narrower and narrower. It's the same thing we saw on the page that had all the normal curves when we did all of our critical z-values. We started 99% is wide, 95 is narrower, 90 is narrower, and 80 is narrower. So as the confidence level, if we go from the bottom to the top, as the confidence level increases, the interval gets wider. Sometimes people think that's backwards of what they think it should be. But really, in order to have more confidence, we have to have a wider net or a wider interval. So you could think of it as like a fishing. If you want to be more certain to get your fish, you have to have a wider net. So in order to be more certain of capturing the true proportion, we need a wider interval. So if we don't need to be as certain, if we only need 80% confidence, then we can use a narrower interval. But if we want to be more certain, if it's something that has to do with life and death, with medical research or something like that, then we want a high confidence, and we're going to end up with a wider confidence interval. Okay, great. So that's one example where we calculated all the different confidence levels, and we looked at what the pattern is between certainty and precision, meaning confidence versus the width of our interval. Okay, I'll see you in the next video.